Hello class, welcome to our studies on matrices. Today we are going to deal with the inverse of a 2 by 2 matrix, undoing transformation, the power of reversibility. So now, what is the inverse of a matrix? The inverse of a matrix A is another matrix in the form A power -1 such that A by A inverse is the same as A inverse by A, which is equal to I. What is the meaning of the I that we see here? The I is the identity matrix. What we need to understand is only square matrix with non-zero determinant have inverse. It means that if I can have the inverse of a matrix, then the determinant supposed not to be 0. Then for a 2 by 2 matrix of the form A, B, C, D, that is the main focal point of this particular studies, the identity matrix I will be of the form I equal to 1, 0, 0, 1. So this is the identity matrix for 2 by 2 matrix. So if A power -1 is the inverse of A, then the product, that is the matrix multiplication of A, the matrix and its inverse, will be equal to the identity matrix I, which is of the form I 1, 0, 0, 1. Now let's get to understand the next concept of these studies about 2 by 2 inverse matrix. So here the concept to understand under this particular study is the adjoint. The adjoint, what is the meaning of it? For a 2 by 2 matrix A of the form A, B, C, D, that is the entries of the 2 by 2 matrix. The adjoint of A is denoted and written as, so if I want to write the adjoint of A, then in short, it will be ADJ of the matrix A equal to D minus B minus CA. It means that we just swap the position of A and D. So for the first entry, it was A when it comes to the matrix A. But when it comes to the adjoint, the entry will not be A, rather be the D. We swap the position of A and D diagonally. Then we add negative to the next diagonal, which is B and C. So if I want to find the adjoint, I'll write the adjoint ADJ of A, then swap the position of A and D. Then I'll change the sign by adding negative to the B and C. So that is how we denote and write adjoint of 2 by 2 matrix. So for example, if I have a matrix A equal to 4, 3, 2, 1, then the adjoint of A will be equal to, so now let's look at where 1 is. It will take the position of the 4. Here is it. And the 4 will also take the position of the 1. Here is it. Then we add negative to the next diagonal, which will be 3 and 2. So negative will be added to 3 to be -3, and negative will be added to 2 to be -2. So if I want to find the adjoint of matrix A of this form, I will swap the position of 4 and 1 and add negative to the next diagonal element. So here, if you want to find matrix B, the adjoint of 8, what is the adjoint of matrix B? Equal to 4, -1, 2, 3. You have to pause the video and try this thing for yourself. When you do that, your answer will be the adjoint of B equal to 3, 1, -2, and 4. So that is how we find the adjoint of 2 by 2 matrix. So now we are on the main idea for today's studies, which is the inverse of 2 by 2 matrix formula. Now let's look at the structure of the 2 by 2 matrix formula. The structure is you find your determinant, you also find your adjoint, then you move to the inverse. So DET, that is determinant, to the adjoint, and to the inverse. That is the structure of the inverse of 2 by 2 matrices. So the determinant check the stability of the matrix, and the adjoint rebuild the structure of the matrix. Then the inverse reassemble to reverse everything that you've done. Everything, or maybe reverse the matrix into an inverse form. So now, given a matrix A equal to A, B, C, D, if I want to find the inverse, then the inverse formula will be the determinant times the adjoint. So the inverse will be determinant will be equal to 1 divided by the determinant of A times the adjoint of A. Now we need to also revise on how to find the determinant of A. So the inverse formula will be of the form the A inverse of the 2 by 2 matrix A is equal to 1 divided by AD, that is A times D, minus BC, that is B times C. That is how we find the determinant of 2 by 2 matrix times the adjoint, and the adjoint will be changing the position of A and D, then adding a sign of negative to B and C. So that is the formula of finding the inverse of a 2 by 2 matrix. And we need to note that A inverse is only possible if determinant of A is not equal to 0. So let's see a practical example of this nature. We have to let A be equal to a matrix of 4, 7, 2, 6. Then first we need to find the determinant. So the determinant will be that E equal to 4 times 6 minus 7 times 2, which will give us 10. So that is the determinant of this 2 by 2 matrix. Then the next one is to find the adjoint, and the adjoint will be 6, 4, and minus 7 minus 2 in this particular direction. So we change the position of 6 and 4. So the adjoint will be 6 minus 7 minus 2, 4. So here the 4 will take the position of the 6, and the 6 will take the position of the 4. Then we add negative to the next diagonal. So the inverse will be the form A inverse equal to 1 over the determinant of A times the adjoint of A. So A inverse will be equal to the determinant is 10, so 1 over 10 by the adjoint that we have here. Then the multiplication will be 6 divided by 10 minus 7 over 10 minus 2 on 10, then 4 divided by 10. When you simplify it, we are going to end up with a simplification expression of the form 3 over 5 minus 7 on 10 minus 1 on 5, then 2 over 5. So that is how we find the matrix of 2 by 2. So let's work on another example, which is to find the inverse of matrix B, which is 2 by 2 matrix of the form 3, 5 minus 2 minus 4. First, we need to find the determinant, which is 3 times minus 4 minus 5 times minus 2, and the determinant of B is minus 2. So we also need to find the adjoint of B, changing or swapping the position of 3 and minus 4, the leading diagonal, then add the negative to each respective element in the next diagonal, which will be minus 5 and 2 when negative are being added to them. Then the inverse of B will be equal to 1 over determinant of B times the adjoint, and it will be 1 over negative 2 times the adjoint. So negative 1 on 2 becomes the scalar multiplication to the adjoint matrix of B minus 4 minus 5 to 3. So we multiply each of the entries of the adjoint of this particular matrix B by the scalar negative 1 on 2, and our results will be negative 4 over negative 2, negative 5 over negative 2. When you multiply negative 1 on 2 by negative 4 and negative 5. When we repeat the same process, we are going to get 2 over negative 2, that is 1 over negative 2 times 2 will be this. Then 1 over negative 2 times 3 will be 3 over negative 2. So you simplify the values or the expression to end up with the final answer of the inverse of B being 2, 5 over 2, negative 1 minus 3 over 2. So that is how we find the inverse of the matrix B. Now let's look at the application of matrix inverse, that is 2 by 2 matrix, to solve linear simultaneous equation involving two variables. So the linear equations of the form ax plus by equal to k, cx plus dy equal to q can be written in a matrix form as ax equal to b. We need to note that, where the A is the matrix A, B, C, D. That is A, B, C, D becomes the matrix, and X becomes the variables, which is a matrix of the variable, that is X and Y, and B becomes the final answer, which is the K and the Q. So if I want to find the variables X and Y, it is like making X the subject in this particular relation. And when you do that, your X will be equal to the inverse of matrix A by B. Let's look at a practical example. We have a question where it is an application question on demand and supply, where we are supposed to find the value of X, which is the price, and Y, which is the quantity, by using matrix application or inverse application. So we are going to solve these two simultaneous equations using matrix inverse application. So here the solution of this one will be first to convert the equation into matrix form. So if I want to convert the equation into matrix form, I write the equation in the root form, that is 2x plus 3y equal to 8, 4x plus y equal to 10. Then I will write the matrix A, which is 2, 3, 4, 1. Then the x will be xy, which is equal to 8, 10. So the next step is by using the relation ax equal to b and x equal to a minus b, a raised to the power minus 1b. That is the inverse of a multiplying b. So in doing that, my a is this matrix, x is this matrix, and b is this matrix. So I'll compute the inverse of a, which will be equal to 1 over determinant of a times the adjoint of a. And when you find the inverse of a, we are going to get 1 over 2 minus 12, that is the determinant, times the adjoint, changing the position of 2 and 1 and adding negative to the next diagonal. And at the end of it all, our inverse will be negative 1 on 10, 3 over 10, 2 over 5 minus 1 over 5. And the final step is to find the solution. How do we get the solution? The solution will be the inverse matrix times matrix B. So the inverse matrix times the matrix B, which is 8, 10. When we do that, we have to remember how to multiply matrix by matrix. So negative 1 over 10 times 8 here, plus 3 over 10 times 10, and that will give us 3. So this is the expression. So if you multiply negative 1 over 10 times 8, you get this, plus 3 over 10 times 3, you get this. Repeat the same process for 2 over 5 times 15 over 5, plus negative 1 over 5 times 2 over 5 times 8, which will be 16 on 5, plus negative 1 over 5 times 10, which will be negative 2. And when you simplify, your results of x will be equal to 11 over 5 and 6 over 5. So it means that your x is 11 on 5 and y equal to 6 over 5. So that is how we use an inverse application to find or to solve two simultaneous equations containing two unknown variables. So we have a practical section here for us to try our hands on them. So given that matrix A is this, B is this, find this matrix, then what conclusion can you draw from your results in A and B? Then using the matrix approach, solve the simultaneous equation 7x plus 9y equal to 1 and 10x plus 13y equal to 2. So try your hands on this question and send your feedback to us for us to analyze your work for you. Don't forget to subscribe to this particular channel and continue to receive the best of high school math education. Thank you.